Hi, I am Dr. K. Sai Prasad Reddy. Welcome to the subject Software Testing. In this session, we are going to discuss about integration testing and the different approaches for integration testing. See, here in integration testing actually there are two activities. The first activity is integration and the second activity is testing. Now, here, what do you mean by the integration? Integration is nothing but adding or putting together. And the testing, so we have to do testing after adding or putting together. See, before starting this integration testing, that integration testing is a white box testing. This integration testing will be performed by the software development team. So how they will start integration testing? Now, see, for example, say if there are 200 requirements for the project, requirement 1, requirement 2, requirement 3, blah blah blah, up to requirement 200. The software developers will take each and every requirement and they will do coding for individual requirements. This coding is also called as a program or element or component. For example, requirement 1, the coding, they have completed the coding and this is one component that is says C1. For requirement 2, they have completed coding. For this component, that is C2, C3, like this. For each and every individual requirements, they will do coding. So here I am representing this coding or program or element or component as a C1, C2, C3 up to C200. Now, during this unit testing, these individual components or programs have been tested. In unit testing, all these individual components are tested and they found they are working perfectly and they found that they are working properly. Now, in integration testing, what they will do? See, in integration testing, the first part is integration, second part is testing. Here, the components, say here I have taken an example for your better understanding. The component C1 and component C9 are added. That means this plus symbol indicates integration. Component C1, component C9 are integrated to form a subsystem called C19. Just I am taking this example for your better understanding. And this component C5 is integrated with component 11 to form a subsystem called component 511. So what do you mean by the integration here? Integration is nothing but adding or putting together of the individual components to form a subsystem. Like say integrated India, what it means if and only if all the individual states are put together, then only that India will form. Like this, all these individual components are put together or added or integrated to form a subsystem. Now, once all these subsystems are done parallelly, these subsystems will also be integrated to form a full system, that is a project. That is the main purpose of integration. Now, here the component C1 is already tested in unit testing and the individual component C9 is also tested during the unit testing. They found that they are working properly. Now, what is the necessary here for integration testing? These individual components may be working properly, but after integrating these individual components and once the subsystem is formed, again we have to test whether this subsystem is working properly or not. How these individual components will be integrated? By means of interface. What it means? See, the component C1 and component C9 are integrated by means of interface. here the interface is also a small piece of code. This C1 is also a code. This C9 is also code. These two individual components are integrated or added by means of small piece of code. During this integration testing, the developers will test this interface, whether this interface is working properly or not. If this interface is working properly, then the subsystem will also work properly. And during this integration, what will happen? The data will be transferred from C1 to C9, or the data from C19 will be transferred to the next subsystem C511. Like this, the data will be transferred from one component to other component, or the data will be transferred from one subsystem to other subsystem. So this integration will happen until the completion of a full system. All the subsystems will be parallelly integrated to form a full system. That full system is nothing but a project. This is integration and testing. Now here, see, this integration testing is the testing with the components put together. During this integration testing, the software developers will validate that the multiple parts of the system interacts according to the system design or not. Because this integration should be this integration should be done according to the project designs only. They are not supposed to do integration as they like. According to the project designs, these components and the subsystems will be integrated to form a system. Now, here, these software developers will validate that whether the multiple parts of this system interacting according to this project designs or not. This is the integration. So, in integration testing, the components, in unit testing, the components can work individually, which are already tested during unit testing, but they may not work together. For this purpose only we are doing integration testing. So what has to be tested? What has to be checked in integration testing? Mainly the software developers will test the interface integrity. That means whether this interface is working properly or not. By means of this interface only, the data will be transferred between these components or the modules or between the subsystems. When this data is transferring from one module to other module, or from one component to other component, or from one subsystem to other subsystem, there should not be any loss of the data, and there should not be any corruption of the data. So when can be that there will be no loss or the corruption of the data? If and only if the interface works properly. This is about integration testing. So this integration testing is a white box testing which will be performed by the software developers. Now here, for this integration testing, basically we are having four approaches, four methods. One is top-down approach, second one is bottom-up approach, third one is hybrid approach, which is also called as CPF, critical part first, and the last is the Big Bang approach, which is also called as a system approach. Now just we will see all these four approaches. Now this is top-down integration testing. This is a top-down approach. See, the project, during this project designs, the entire project will be divided into layers. So here in this diagram, layer 1, layer 2, layer 3, there are 3 layers. Now, the name itself indicates the approach top down. That means we have to start the integration from top layer and we have to proceed towards the bottom layer. This is called top down approach. So in this top layer, that is layer 1, the component A is present. In layer 2, B, C, D components are present. In layer 3, E, F, G components are present. Now during this top-down approach, the developers will start integration from top layer and they will proceed towards the bottom layer. Here the top layer, in the top layer component A is integrated with the second layer BCD to form a subsystem ABCD, and this subsystem ABCD is integrated with the bottom layer components EFG to form ABCD EFG. This ABCD EFG is a full system. Now this project is completed. So integration will be done to form a project, to form a system. This is integration testing of top-down approach. Now here see, in top-down approach, the tests are conducted as each component is integrated. Test the top layer first and then integrate the next layer components. So then combining all these subsystems that are called by the tested subsystems and testing the resulting collection of the subsystem. So up to what we have to do? We have to repeat this until all subsystems are incorporated into the test. And here the stub is a special component in top-down approach. The stub is a special component in a top-down approach. What is this stub? Stub is nothing but a dummy component. It is not a real component. When this stub is used, for example, this stub is used in top-down approach. For example, here during this integration, for example, component F is not readily available due to some reasons. That is, the coding or the unit testing of the component F is not yet completed. That means at the time of integration testing, at the time of integration, component F is not readily available. So just because of non-availability of this component F, we cannot stop the integration and the testing. Then what we are supposed to do? In the place of component F, we will use a dummy component that is called stub. Because just because of unavailability of a component F, we cannot stop entire process of integration testing. So in the place of component F, we will add a component called stub. Stub is a dummy component. It is not a real component, right? So once the component F is readily available, then we will remove this component, then we will remove this stub and we will add this component F. This is the stub. Now, the stubs do not perform any real computations or cannot manipulate any real data. When the stub will be removed, the stubs will be removed once the unavailability component is readily available. Then only we will remove this stub. Just like a supporting component stub. It is a supporting component. It is a special component. It is a dummy component. It is not a real component. When to use the stub? A component being tested may call another that is not yet constructed or tested. So solution, when the component is not readily available, then we are supposed to use the stub in the place of that particular component. Right? For what purpose? This stub will simulate the activity of the unavailable component. Right? This is the stub. This is a top-down approach. And the second one is a bottom-up approach. That is a reverse process to the top-down. So here, in this system, in this project, we are having these three layers, layer 3, layer 2, layer 1. In bottom-up approach, the software development team will start integrating the components from the bottom layer and they will go towards the top layer. Here in this diagram, E, F, G are the components in the bottom layer. Now here, the component E and the component F, individual components are already tested during the unit testing. Now what they are doing, this component E and the component F, these two are getting integrated with the component B as shown in this diagram to form a subsystem BEF. This part is completed, and here the component G, here this component G is integrated with the component D to form a subsystem DG, and the remaining component C, this will be added. Now the component EFB is integrated with this top layer, and the subsystem GD is integrated with this top layer. The remaining component is integrated with the top layer to form the entire system. This integration or this addition of this component, individual components, will be done according to the project designs. We are not supposed to do the integration as we like. According to the project designs only, the software developers will do integration, and then after integration they will test this subsystem. Here after integrating this component G with the D, this subsystem is formed, that is a DG. This will be tested. After completion of this subsystem testing, then these subsystems will be integrated again to form a full system. This is called bottom-up integration. In this bottom-up integration, there is a special component called the driver. The driver is a special component which is used in bottom-up integration. Whereas in the top-down integration, stub is a special component. See, in bottom-up testing, the component in the lowest layer are tested individually, and the next subsystems are tested that called the previously tested subsystems. That means all the subsystems are tested and then they will integrate it. This will be done, this will be repeated, that is integrating all the subsystems will be repeated until the completion of a full form of a system, that is full form of a project. And the output of this integration testing, the output of this integration testing phase in software development life cycle is a full form of a system, that is an application, that is a project. That means once the integration testing is completed, then the entire system will be formed, the entire project will be formed. This is called bottom-up testing approach. And the third one is hybrid testing approach. The name itself indicates a hybrid, that is mixing. Here in the hybrid approach, both the top layer and the bottom layer integration are clubbed or put together, right? Here say in this top layers test A, and here the bottom layers EFG are there, right? This EF components are integrated with the component B, that is we are going from bottom to top to form a subsystem BEF, and here the test A, that is the component A, is integrated with the BCD to form a subsystem ABCD, and the component G is integrated with the D, right, to form a subsystem DG, and all these subsystems will be again integrated to form a full system, that is called ABCDEFG. That is, see, both the top-down approach and the bottom-up approach are implemented at a time to complete, to form the system. This is called the hybrid testing approach. Next is this hybrid approach combines the top-down approach with the bottom-up approach. The system is viewed as having three layers: a target layer in the middle, a layer above the target, a layer below the target. That is, what is the target layer? The middle of this layers is the target layer. So they will in the bottom-up approach, they will start from the bottom layer and they will go for the target layer. From the top-down approach, they will start from the top layer and they will go towards the target layer, right? Yeah. Then last is Big Bang approach. What is this Big Bang? See, once all the components are tested in unit testing, like say C1, C2, C3, C4, like this, say for example there are 200 components in the project, from C1, C2, C3, blah 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 up to C200. Once all these components are tested individually in the unit testing, then all these components, all these 200 components will be combined at a time. This is called Big Bang. That means all the components, all the modules, all the elements, all the programs will be integrated at once. This is called Big Bang. So this Big Bang approach is a non-process oriented organizations will approach. So that means who will do this Big Bang, who will implement this Big Bang testing? Generally, non-process oriented organizations will use this Big Bang approach, right? What is this Big Bang approach? In Big Bang approach, all the components or all the modules or all the programs will be integrated at once. And here, what are the advantages of Big Bang? There is only one advantage, is that no stubs or no drivers are required. Because when can we go for a Big Bang approach? If and only if all the components are readily available, and if and only if all the components of the project is already completed this unit testing, then only we can go for Big Bang testing. So as all the components are readily available and all the components are already completed unit testing, then no need of stubs or drivers. So this is only the advantages in Big Bang testing. And what are the disadvantages? Hard to debug, hard to check the interfaces. Because why this hard? The debugging will become tough. And why this interface checking of the interfaces will become hard? Because all the components are integrated at once. That is why it will become little bit of hard to debug and to check the interfaces. And the location of the defect is difficult to find because all these components are integrated at once, right? So these are all the four approaches in integration testing. One is top-down approach, second one is bottom-up approach, third one is a hybrid approach, fourth one is Big Bang approach, right? Yeah. If you like my sessions, please subscribe my channel and share and like my sessions. Please share my sessions with your friends and with your students groups, those who are looking for the jobs in the IT industry, right? Thank you.